Hello, everyone, and welcome to Our Ladies Cologne. My name is Sarah, and I'm here with my wonderful co-hosts, Gabe and Livia. Today, we have a very exciting talk. Veerle will be sharing her insights into the world of large language models. And well, this world is often associated closely with Python. Um, so we are especially excited that Veerle will show us how to approach and work with large language models from R. And yeah, with that, I'm happy to hand over to Veerle and thank you all for being here and enjoy the talk.
Hello everyone. I'm going to do a quick introduction. My name is Veerle, and I'm a data scientist from origin. I worked a couple of years as data scientist in various industries, energy industry, and pharmaceuticals. Then I went into entrepreneurship and I co-founded or was co-director at a company. Now I'm having my own company, mainly focusing on giving R and Shiny trainings here in the Netherlands, but also online, and doing a consultancy. And I recently wrote a blog series on the Shiny blog, which was a three-part series about LLMs, and with both examples side by side in R and Python, where I basically talk about from scratch what LLMs are in super simple, plain English, and how you can use it and use the packages that come with it, ellmer and chatless. Chatless is Python, ellmer is R. How you can use those packages to programmatically talk to APIs and eventually build a custom app around it. Today, I'm going to highlight part of this series because in this series, I also talk about something that is called tool calling. And today, I will highlight that specific part. If you want to learn more about LLMs anyway, and want to learn all the ins and outs about the ellmer package, which I will discuss today, you can also head over to the blog series. And in the materials that are up on GitHub, I shared them in the chat. You can find slides and also links to this whole blog series. So today we talk about tool calling R with this lovely package called ellmer. This is kind of the rough program. First, a little introduction about LLMs and tool calling, then how you can use the ellmer package for something called structured output. I'll come back to that, what it exactly is, and tool calling in R. And then we will head over how you can use ellmer in Shiny as well to build a custom app around it. And then we have some time for questions. All right. A lot of people think that LLMs are magic and they kind of type their question into ChatGPT and the thing answers with something and you're like, whoa, this is amazing. It returns code, it works, it can understand me, it can do all kinds of stuff, make jokes, these days even generate images and stuff. And you're like, whoa, this is really cool. What is all happening behind it? Well, the question is actually not as sexy, as it sounds, because it all comes down to something as simple as statistics, unfortunately. And statistics is really old and here for a long time, but that is the basis of LLMs to begin with. So let's go back to what LLMs are and what the name actually is. And most people will know that are here, I presume. But it's a large language model. It's trained on huge amounts of text data. So I'm not talking about a couple of books. No, I'm talking about billions and billions of sentences, words, text retrieved from books that are online, but also conversation with people, social media, of course, all the text that you can possibly imagine is being trained upon. The bigger, the better, often such a model is. And it is designed to predict and generate human-like language. So that's important to keep in mind. An LLM is not a magic machine. It's simply trained, it's built to talk to you. And what it actually does, there's a model behind it. It recognizes patterns in that huge amount of data at scale. And this is what I said, it's quite boring because it all comes down to statistics. Eventually, what LLMs do is make use of something called transformers, which are all, at the bottom. But at the top of this tree is still statistics. Part of statistics is machine learning. Within machine learning field, you have traditional machine learning support vector machines, decision trees, all the stuff that we data scientists use. Then we have a little subfield there, deep learning, and field within that, neural networks, and then transformers. And that is actually what is powering these LLMs. And that's essentially also where this hype all comes from. But the thing is, these models are designed to simply based on words that are given to them to predict the next word. And it does it over and over again. So if it's writing sentences, it's constantly weighing, okay, this is now the words that are here. I need to predict the next word. What is the probability that this next word is most fitting in this particular context? That is kind of what it does. But because of these large language models are trained at such a huge scale on literally all kinds of text that you can think of, these models also start to show emergent abilities, which are basically tasks that they're not trained to do because they're simply trained to do predict next words. But they can also do other stuff that we didn't necessarily teach such a model. Things like writing code, translating from one language to another, but also do these things like, hey, can you write something in pirate speech? Or can you make a joke out of this? Or, really thinking like you're talking to a human. This is because of the scale. Somewhere on the internet, a person made a joke about, I don't know, a pirate or said something in pirate speech. Somebody wrote that code snippet. And then what an LLM does is looking at those code snippets that it was trained on or these jokes it was trained on, and then weighs constantly, okay, in the context that was given, what is likely, for example, to be the next variable in my code snippet that I should insert there, or the next function that I should use. So that is constantly what the model is then doing, only super fast. So LLMs are, we all use them. They are good at generating human-like text. We can talk to them. They make nice sentences. We give them an unpolished version of our paragraph or our blog, and they turn it into a polished version that sounds, maybe a bit shallow because it's still a machine writing it, another human, but it generates good language. You can also have conversations. It can summarize text really well, also answer questions. I mean, if you give it, for example, a reference to a book or upload pages of a book and then ask questions about it, it can answer that perfectly fine. And it can also write and debug code snippets. LLMs are good at that. You get good results. But LLMs are not good at everything we throw at them. And you've probably seen that before. And what's even worse, LLMs can give you an answer where they say, oh, this is the answer. But they can be, super wrong. LLMs can hallucinate, meaning that they make up things that aren't really existing. For example, if you ask them to write code, they might come up with packages that don't exist, functions that don't exist, things that don't make sense or that break. And they also are not good at literally calculating things. We've seen all the examples on social media, probably when you ask a model to count the R's in the word blueberry, for example, it will come up with a random answer. Maybe 3, 1, 2. It is kind of, it's not actually analyzing that word and counting the letters. It's mainly looking at your question, seeing it as, a bunch of words, and then trying to, given the context, predict what its answer should be or what the next word should be. It's not like there's a program running behind it that is doing calculations. So LLMs are often really bad at counting, performing basic calculations, and also because it's trained on huge amounts of data, it's not necessarily trained on data that's there right now, right here. It can't provide you with real-time or up-to-date information. If there's a model that already does that, it needs to be built in, but it's not inherent in what a large language model is doing. So that is a bit problematic in some cases because sometimes we do want to get these things right. So as I said, why do LLMs hallucinate? They are simply predicting, or they were trained on text, and they simply look at patterns in that text and they repeat that. They don't really understand things. They don't calculate things. They don't have a program running behind it. There's not a Python or an R session behind it that is actually executing code. So when you ask them questions outside of the training data, so for example, to write, if you would now ask it to write about the ellmer package, it might not know that because the ellmer package is relatively new and the model might not be trained on that. So it will try to give you an answer. I mean, it was trained to do that, but it will, hallucinate things, saying that ellmer is a package designed for something different, or make up functions that are not in the function reference of the package. And as I said, they don't execute code. LLMs don't do that. There's not a Python or R sessions running behind them. So yeah, things like functions, writing functions for LLMs or performing calculations, asking for real-time data. It's not a job for an LLM. So it's not built to do that. So you also must not try to make them do that. But luckily, we are still in the loop. We humans. And we do know how to be accurate because we do know how to use Python or R to execute functions. We know how to count things. We know how to check what the current weather is outside. We know how to check, get APIs and get access to the internet to retrieve some real information. And these real functions that we can build, we can actually execute. And that's when we get into the territory of tool calling. So what is tool calling? Actually, it is a technique where we use an LLM, or where an LLM gets access to a set of functions that we have generated. And those functions do specific tasks. So for example, we could create a tool that fetches live weather data. And when the LLM is then asked about the weather, the LLM is not trying to hallucinate up an answer about, well, maybe it's sunny. No, I will just say it's sunny. No, the LLM asks the tool, which is a function that is running somewhere, to do its thing. So probably call an API from a weather service, then return the results. And then the LLM is using that data to come up with its answer. So this way you can enhance the capabilities of an LLM by giving them extra tools that do these things that LLMs normally don't do, counting, retrieving data from somewhere, running another model behind the scenes or whatever. You're giving them actual information instead of that you are making them guess. So this is constantly, it's called tool calling because this LLM is then constantly calling this tool that you have written to strengthen its own answer. The cool thing is that how it's designed, LLM and tool calling, is that you don't have to tell necessarily the LLM, hey, I've written a tool. I want you to use it now to fetch the live weather data. No, and we will see that a little bit later. We can actually just say, get the current weather and give me some activities to do in this current weather. And the LLM will know, hey, you have registered a tool here. You have given the description for this tool, which fetches live weather data. I should probably use that tool. You don't have to tell an LLM then in that case, I want you to use tool A or B or C. No, it is kind of inferred or yeah, it's kind of inferred from all the function arguments that you give it. And we will see that in a bit. So why would you want to use tool calling? Well, you can, design tools that are really specific for your use case. You can be more accurate. It's also more efficient because you can let the LLM focus on what it actually was designed to do, namely just generate text and not do all the other stuff that we need, real answers for. And also reduced hallucination, which is of course great because nobody likes an hallucinating LLM. So how do we do that? With our lovely ellmer package, which has the cutest hex logo ever with this little ellmer elephant. I think Hadley made it. I don't know. Anyway, I think it's really cute and colorful. So we're going to use ellmer to generate a tool and then an LLM call that. And that's pretty easy to do with ellmer. So how are we getting started with ellmer? So what we need to do first is we are going to talk to an LLM. That LLM is hosted at some provider. So we need to have a key. we need to pay, obviously. Nothing comes for free. There are also free models, by the way, with free tokens or a tier that gives you a number of requests to use for free. But in my example, I'm using Cloud from Anthropic. So I need an Anthropic API key to make this work. So what I would first do when I'm starting an ellmer project is putting that key into my our environment file as an environment variable. Then it's also good to know, and I'm just giving this disclaimer because it happens. Never ever push this file to GitHub, guys. Don't do that because everybody will have your key, and that you don't want that. Luckily, GitHub, for example, has some protection on it. If you are pushing keys, especially things like Anthropic API key, it will give you a push warning. It will not even let you push it, which is nice, but it still happens because there are a lot of examples out there on the internet where API keys are published. And we're not going to be one of those people. Then we're going to install ellmer. It is available on CRAN. A new version is hopefully being released this week or next week, but it depends a bit on how fast things go into holidays. And then we can start with our first conversation. It's actually really simple. We first initiate a chat object, and in the chat object, we specify the provider model. So in this case, we have the provider, which is Cloud, or actually Anthropic recently rebranded its. Okay, now I'm going to rephrase it a bit. Anthropic had a model called Cloud, and they're recently trying to rebrand it so that everything becomes under the Cloud model. So now also the provider is called Cloud, which is a bit confusing, but Cloud is kind of the old Anthropic. So what we do here is we provide a string with the provider / model. The provider in this case is Cloud. The model that we're using here is Cloud Sonnet for 5. You can get a string of other models that are available on every provider's website. So also if you're using here OpenAI, and maybe you're using Google Gemini, you're using maybe even models that are locally hosted or hosted at a cloud service provider like AWS Bedrock or Azure, or literally any model you can probably think of, and especially the most popular models are available in ellmer to use. There's a whole list on the ellmer website that you can use here. And what we then do when we have a chat object, we simply chat to it. So yes, we have a lot of chats here in this little piece of code 4 times. So we have a chat object, then we call the chat method on that, and we can ask questions there, just like you would normally do in a ChatGPT window, for example, just like you're chatting. So in this case, we're using the model to come up with activities for somebody with an 11-month-old baby, and that happens to be me. So yeah, I'm all a baby teen, you can say. Now, the answer that will return in the console is, yeah, sure, I can do that. Here is a list of activities. We're not going to go through all of them, but this streams on your R console. And we will also look at that live a little bit later. So this is pretty simple to use to get started with ellmer. So about this chat object, as you've seen here, in line 3, the chat variable, it's a stateful object. That means that it remembers what the previous conversations were. It's just like the chat window that you can ask it questions back about things that you asked maybe 5 turns ago to get back to it because it remembers it. As I said, you give it a provider model string. So we use Cloud Sonnet. And you can also give it a system prompt, which we will see a little bit later. And we can pass parameters if you want to via the params argument, where we can tweak model settings. I'm not going to get into that today. There's a whole bunch of things you can change about the model. For example, how creative it should be, or perhaps it shouldn't be creative. That's all kind of technical things you can tweak about an LLM. Then a word on the system prompt versus user prompt. If I go back a little bit, what we did here in line 6, can you tell me some fun things to do with an 11-month-old baby? That's a user prompt. At this point in time, we're asking the LLM that simple question. It's a part of our conversation that we're having. That's the direct user prompt at hand. But there's also something that's called a system prompt. It's a higher overarching prompt that you can give an LLM, where you basically set some ground rules. You can give it some things like, I want you to use British English, or I want your answers all to be in this and this format, or I'm going to provide some extra context that's basically relevant for the whole conversation. It's basically you telling the LLM how it should behave. It's a stable context. It doesn't change over the course of the whole conversation. The user prompt that we used there was a specific question at hand. It was the request that you're making right now, and it's dynamic context. That's important. And if you are going to develop with LLMs and using their APIs, you will often notice that the bulk of the stuff you are prompting an LLM to do should be in the system prompt, not in the user prompt. And we're going to see that later on. Often the system prompt can be, a big file that might be 3-4 pages long or whatever. And the user prompt is something simple as, please execute the task I gave you. You shouldn't provide context in the user prompt. That should be in the system prompt instead. So let's say here that we have a system prompt about this baby activities thing that we want the LLM to do. It's in a markdown file. And often markdown is a good choice to put your system prompt in because it can be consumed easily by any language. If you have it in a separate file, you can easily version track it as well. And if you're using a markdown file, you can also use the markdown markup, like headings, bullet points, and all kinds of stuff, which makes it also more readable for you. But let's say that we have now this very simple markdown file, and we're given here some overarching context, like, hey, you're an assistant that helps parents by generating a list of 10 basic activities, blah, blah, blah. Each activity must include 3 things, in this case, a fun score, estimated duration, and short description of the activity. What we're doing then, we're changing our code to get a prompt file. And what we're then going to do is in this chat object, we're going to say our system prompt is this particular prompt file, or the content of the prompt file that we have here. And then I can ask a question for my current request at hand, my user prompt, what can I do with my baby today? And now in my system prompt, we know already the baby is 11 months old. We know that we want a list of 10 activities. We know that each activity should have 3 of these specific points. So our user prompt can be very short in this case. And then the result is something like this. So 10 fun activities for the 11-month-old baby, indeed with a fun score duration description. All sounds good, right? Keep in mind already, look a bit at what the answer here looks like. We have a fun score here. It says 9 out of 10. The duration says 15 to 20 minutes. It kind of looks the same over all the activities. But if you would generate this next time, would it still look the same? Or would the LLM say not 9 out of 10, but simply 9? Would it say 15 to 20 minutes or simply 15 minutes? These things matter later on, especially when you're going to use the results, in this case, the 10 activities, in a program that you're going to write. Okay, so we now had this system prompt, and it was in there that the baby was 11 months old. We want to use this thing for other mothers or fathers as well. So we want to make the age dynamic. In ellmer, we can do that by using these double curly braces. So what we did now is that we have this age within curly braces. And then we can use this very clever function from the ellmer package, which is called interpolate file, which can then interpolate your variables into this file. So now we have defined our age, which is 11. We have the location of our prompt file, which is this markdown file. And what we're then doing is we're generating the system prompt by interpolating the age. And the result is that we get the exact same content of the system prompt as before, because age is 11 in this case. But now it could be anything else as well. It could be 12-month-old baby, or 5 months, or 4 months, or whatever. Okay, some tips on the prompt that we've seen. yes, prompt design is a real thing. People were making jokes about it when LLMs just emerged and stuff like that. Oh, there are prompt engineers or whatever. Is that a real job? Um, Actually, it does matter a lot how you phrase your system and user prompts. You can get very, very different answers depending on how you write things, how clear you are, how much repetition you are giving the LLM. If you put things at the end of your prompt or at the beginning of your prompt, if you put it in bullet points or not in bullet points, or there's a lot of things you can tweak to get better answers out of an LLM. And I also provide some tips on the Shiny blog about that. So it's also important to give enough context to an LLM. Context is basically all the extra information that you're giving. In this case, for the baby, we provided that we want to have 10 activities, that we have a baby that's X months old, but we could also have provided some information about the baby itself. For example, things that the baby likes or the baby dislikes, or perhaps the baby can already crawl or not crawl. Those things are all important for the list of activities that the LLM is going to generate. And generally speaking, the more context you provide and the more specific this context is, the better results you are getting. As I said, it's good to format your prompts. For example, use Markdown to make it readable for you and for the LLM, and so that you can also track it on Git if you want. And for now, we have this system prompt, which is 3 lines long, and you're like, why should I track that on GitHub? Doesn't matter a lot. No, but if you are going to write real programs around it, you will notice that your system prompt is actually getting really, really long. And only a little tweak in it can already cause your LLM to go, a completely different direction. So yes, you want to make sure that you track that file so that your best prompt is always, stored safely. Okay, so back to the output format. So in our system prompt, we simply ask the LLM to provide a list of activities, 10 activities with these 3 fields: fun score, estimated duration, description of the activity. We could also make it more specific and tell the LLM that we want to return it in JSON format or a Markdown table or, I don't know, any kind of format that you can think of. Now it kind of randomly generated a thing in 3 bullet points, and it kind of invented that itself. But since we didn't specify what the format was, it could be different the next time. Playing with an LLM, if you ask the same question today versus tomorrow, you will get a different answer. There's just a random seed in there. So if you don't specify the output format, your output might also look different. And that's not handy if we want to use the results, programmatically, because we're working with things programmatically, we want things to be consistent. So it's not always reliable what the output is. Luckily, we have a solution for that, and that thing is called structured output. Some LLMs, most of the models actually support the use of structured output, where you can give the model a very specific type specification of what your data, the output data, should look like. So what does that look like in R? Getting a bit to that. So yes, as I said, structured output is just what type your output should look like, what columns should be in there, what the type of those columns is. And it tells the model, just not what to output, but also how to output it. And often this is much better to use, so structured output, than just telling an LLM to generate a JSON, for example. If you tell an LLM to, I don't know, output a format in JSON with these 3 fields and whatever, it will do that. But sometimes it will format it as a code block. So you will have these 3 backticks there, and then curly brace JSON, whatever. Sometimes it's not. Also, structured output is more reliable than just telling the LLM to do it, because if there are no constraints on what the model actually should look like, you can also see things like missing commas, non-parsable JSON, stuff that is just a bit weird. So structured output is a good solution for that. So what do we need in ellmer to do that? To return structured output, we need 2 things. We need a different function, which is conveniently called chat structured, and we need to provide this type specification, which I must admit looks a bit weird in R, simply because we're not used to do it like that. So let's see what this type specification looks like. So here we have a data model for our baby activities. This is actually, these are all functions type, object type, integer from the ellmer package. What we're doing here is we're defining a very big object. This is the type object. And within there are two sub objects. So first the baby age in months, which is an integer, the age of the baby in months. And then we have activities. And this activities is an array. Also something that we're not necessarily familiar with in R, more in other languages. But this array is basically the equivalent of a data frame-like structure in R. So this array consists then of another type object again, with things where we specify that the name of the activity should be a string, the fun score should be an integer, score from 1 to 10, the duration in minutes should also be an integer. And if we specify it like this, remember what our model previously said, it says it set a fun score 10 out of 10, 9 out of 10. With a type specification like this, you don't get that because we said that it needs to be an integer. 10 out of 10, 10/10 is not an integer. So the model is kind of forced to only give you a 10 or only give you a 9. Same thing for the duration in minutes. It said 15 to 20 minutes. 15-20. That's not really nicely parsable if you're working with it programmatically. If you do it like this, no, we need an integer for that. It will come back with 15 or 20, not both, not something, that can be parsed more difficult. So let's see how that works. So now we have a prompt file, we have our age, then we have our full system prompt. This all looks the same, only now we're using chat structured. We still have the same user prompt, what can I do with my baby today? But now we specify that we are using a data model, the data model that we defined here. So this is that object. And the result looks like this. So we now get a nice table, it's actually a tibble for the tidyverse lovers that can be consumed in R very easily. So now we have this tibble, simple data frame, name, fun score, duration, and all the types are already good and correct. This is an integer. This is also an integer, character. And now we have something that we can consistently work with because this table, the column names, the type of those columns will look exactly the same every single time, which is really nice. Okay, but we were here for tool calling. I know. So yes, let's get back to that tool calling. We now have this list that we can generate on a very consistent basis. That's already nice, but of course our little program is not perfect yet. Because what we're going to do with our 11-month-old baby also depends on things like the weather. We're not going to go outside if it's raining, and if it's very hot, we might want to go outside or to the swimming pool. Also, it's nice if we can provide a location on which we can base the activities. We're not going to the Eiffel Tower if we're in Amsterdam. We need to be in Paris if we want to visit the Eiffel Tower. So these things, this context matters. And it's easy to provide location. We can just do that in our prompts, just like we did with our age. But it's more difficult to work with live data because, as we know, LLMs don't have access to this live data. So we need to write a tool for that. How do we do that? With a simple R function. I'm not going to get into the nitty-gritty of this function. This is a normal R function. It has nothing to do with ellmer yet. It's documented with Roxygen here, just like how you would document a function in a package. And it retrieves the current weather based on a city name. What it's doing here, it's getting some geo locations of that city. Then it's retrieving the data from the Open Meteo API. And it returns 4 things. The name of the city again, just to confirm we're talking about the correct city. Temperature in degrees Celsius, the wind speed, and a weather code, which is a code that could mean that there's a hazard going on, or that it's calm weather or relatively sunny. All these I'm no weather woman. I don't know the specifics of talking about weather, but all these kind of weathers have a specific code. So that is what this simple function returns, this R function. What we need to do then to turn this into a tool in ellmer is wrap it in a function called tool. So we wrap it here. This is our function, get current weather. And then we give it a description, which is for the LLM to consume, so that the LLM knows what this function is about. It returns the current weather for a given city. And it has an argument. The argument is a string, the name of the city for which to get the weather, and it's required. So this is actually all the information that we tell the LLM. Obviously, from the function, we already know, we're R programmers. We already know that city is required. We know from this description that what the function does. We know what the parameters are, etc. But we need to tell the LLM that as well. There's also a convenience function in ellmer to automatically turn your Roxygen comments into what you're seeing here, which is really nice. So you don't have to type things twice. But in this case, we can just write it like this. So then we have our tool, which is also called get current weather in this case now. What we then need to do is we need to, these are the instructions for the LLM. Then, of course, we need to attach it to the chat that we're currently having with our LLM. And we do that then with the register tool method on our chat object. And that's what it looks like. Now, we also need to update our prompts because we're now working with a city name and we are working with basically two things. Now, we're asking the LLM to retrieve the weather, then return the data in a nice table based on our data model, and come back with this answer. So our prompt looks a little bit different now, with now a dynamic city in it, and some extra instructions on how to return the data. In this case, we say that it needs to return JSON results only. Under the hood, ellmer will transform this JSON into the table that we just saw. For an LLM, it's generally easy to work with JSON because it's a very universally accepted format to work with data. So that's often a good bet to make sure that the LLM does get it right. Okay, but there's one problem because we're working with structured data and we want to work with a tool. Now, if you read the ellmer documentation closely on the ellmer website, it will say, note that structured data extraction automatically disables tool calling. That sucks because we want to use structured data. We also want to use tool calling. So how do we do that? How do we combine it? Well, we need to use a two-step process here. First, we need to call the tool to get the current weather. Then we use that weather information to do the structured chat. And remember, the chat object in ellmer was stateful, so it will remember these previous terms. Our system prompt is already, designed for it because it had two tasks in there. Let me get it back. Task 1, we numbered it even, was retrieve the current weather. Task 2 is generate the list. So what we can do now is we can give the LLM two tasks as well and refer back to the numbered tasks that are here. So what we would say then is first we do a regular chat, which uses the tool. So we say execute task 1, get the weather. And then we have a second task where we use chat structured, where we say, okay, execute task 2 now with a specific data model. So let's see how that works. I'm going to this thing away, get this on the screen. If it fits there, and do that thing away. Is it big enough? Can we see that? Good. All right, so this is what we just saw. By the way, if you don't know this IDE, what you're seeing here, this is positron. That is the kind of the, I would say, well, follow-up of RStudio. I think it's going to be a follow-up of RStudio. RStudio is still there. Anyway, side step. All right, so we need a couple of libraries here. here's also a specification of the package versions that you need to have at least. So these are, most of them are the latest versions. And this is also, these are all in the examples folder on GitHub that I shared in the chat. This is our data model. This is our function, the simple R function, get current weather. Then we turned it into a tool here. Okay, ignore that warning message for a bit. Then we have a full system prompt. So that's the interpolated system prompt, where we now say retrieve the current weather for Rotterdam, where I live, and do activities for a baby that's 12 months old. 12 months old. Actually, my kid is next week, 1 year. So yeah, he's almost 12 months old. So I need to change that here. Then we register or we initialize the chat object, like so, with our cloud model and our system prompt. We register the tool, get current weather. Then we do the first task, and you can actually do that. Just we don't need to specify it to an object. Execute task 1. What we will see then is that it's actually making a tool call. You already see this. That ellmer is making a tool call, namely get current weather with a city, Rotterdam. And this is what it returned in between in JSON. We asked it to return it in JSON as well. So the city Rotterdam, temperature now is 10 degrees, weather code is 3, whatever that may be, I think. Dry, doesn't rain, or whatever. And then we can execute task 2. Now, task 2 will know the answer here, that we are in Rotterdam, that it's 10 degrees. So the activities that it's going to generate here should take into account that it's this kind of weather right now. So probably proposing some indoor activities. Chat structure will return the results at once, so not streaming. If you're using the normal chat method here, it will stream the results on the console. It's like in ChatGPT, you can actually see things being typed and returned as they arrive. With chat structure, it returns all at once. So now we have here some extra information as well. Our city was Rotterdam, the baby age, 12, temperature, it's cloudy. And then we have our table with our 10 activities. So that's pretty nice. And that's uses a tool that uses live information. And obviously you can go much further than that, than simply just retrieving the live weather data. You can also use it to get all kinds of sort of information that enhances the capabilities to perform calculations, to run models in the background that you've written in Python or R, or do functions that you can only get in R and whatsoever. You can go fully nuts there. All right. Then looking at the time, I want to move on how you can use this in Shiny as well. So that is actually the other file that's in there, which is ellmer Shiny. There's a whole bunch of text here that you can read, at your own pace later on, which gives a little bit more context. It works the same as the code that we just saw. So here above our UI and server, we define a system prompt file. We have the data model here. We have our tool. This is our function. Then we have converted it into a tool here. And then we are writing the UI, which is a simple UI that just displays some value boxes and a table, which you will see in a little bit. And works, and that is very important, works with a input task button and the extended task functionality from Shiny. I'm not going to explain that all to you in 15 minutes. I can't. It's about async programming. It comes down to this. In Shiny, if you want things to happen asynchronously, so not be blocking your app while we are fetching the results from LLM. Normally, if you would do that, not async, the Shiny session just stops and waits until the LLM is finished, until you can presume, which is very annoying in a web application. In a web application, you don't want to have to wait for anything. You just want the thing to keep running while it fetches the result for you. In order to do that, you need to program asynchronously. And in Shiny, since Shiny 1.8, you can use extended task for that. And it looks a bit like this. And you use that in combination with this input task button, which is a special button from BSLib. It looks like this. Here we specify an extended task. And it's basically a function where we provide the arguments, in this case, the system prompt that we're going to use and the data model that we have. And then this looks exactly the same or almost exactly the same as we just did. So we initialize our chat, we register our tool, then we execute the first task. Only now, keep in mind that we're using not chat, but chat async. We wait for the results because we do need the results from the weather first before we can start with the second task. So when this chat res is done, then we execute another function where we then use chat structured async to retrieve the second task. And then we bind this task button from the UI to this thing. So let's just see what it looks like. It's always much more fun. I'll actually do that a little bit bigger. I'll do it in a separate browser. It's a bit nicer. So what this looks like now is here we have the parameters. Users can simply change that. I'm going to get my baby activities. Then we have a nice bouncing waiting icon because we do have to wait, but this clock keeps ticking every second, you'll see. Our Shiny session is still responsive while we are fetching results. So in the meantime, our users could do other things, could view graphs, could watch tables or whatever. And once it's finished, then we have everything nice in a table with some value boxes with, some statistics. But the thing is, since that we are using here a structured data output, is that we can reliably show this in an application. We can reliably say, okay, there is a column that is called fun underscore score that we can use to calculate an average upon. There is a duration underscore minutes column that is an integer where we can calculate an average on. And that's all because we specified that it needs to be a structured output, which helps us a lot in processing the output of an LLM reliably. Now, the tool call, as you've seen here, helps us a lot with retrieving or enhancing the capabilities of an LLM to only show results that are relevant for this weather for this particular place. Right. The last thing that I wanted to, because looking at the time, and I want to leave some room for questions, the last thing that you might be thinking is, oh, okay, sounds fun. I kind of can see the benefit here. How would I use this in my work? Because at my work, we're not going to generate tables with baby activities, probably. I want to give you one example out there that uses tool calling for its capabilities, and that is called query chat. And I'm going to show you that. Query chat is a package which is a drop-in component for Shiny, both available in R and Python. And what this actually does is it turns your natural language questions into SQL. So let's just say that the system prompt for this particular package was, hey, people are going to give you a question. I want you to translate this question into SQL. Then with a tool call, query chat is going to take that SQL, run it on a DuckDB database, an in-memory DuckDB database, execute it on your data, and fetch the results. Now, query chat enhance the LLM to actually get results from your data by calculating whatever the SQL has given. The LLM is not running that SQL. The LLM is not computing averages of columns. The LLM is not filtering your data. No, the LLM is simply doing what it's good at, namely writing SQL code, passing that SQL code to a tool that is actually going to execute it. That tool is running in your R session. So it's using DBI to actually connect to your DB database, then execute it. Then R is going to crunch the numbers and whatever, and return the averages and return the filter data. passing that back to the LLM, and then the LLM is going to say some interesting stuff about it. So let's say that the average of the fun activities was 20 minutes, and then the LLMs say, well, within 20 minutes on average, you can do some pretty fun things with your baby. So this is actually a really cool application of tool calling in the wild, I would say, where it goes much further than just retrieving some live weather data. But I hope this will make clear or gives you some inspiration as well on how to actually use tool calling in a professional setting too. Right.